This lesson is from Mrs. Cucci's College Now PreCalculus class. We are on lesson 5.3, day 3. We're finishing up the lesson today. Should be a short one. We left off on page 1.21, or right around there. We need to find the given function value and the quadrant restriction. We need to find theta. We're on the second one. Cotangent theta equals negative 0.1611. We're dealing 270 to 360, which we know as the fourth quadrant. Okay, so we know that since we're looking for the angle, what we're going to want to do is take the inverse. Now, if you remember from last year, we do not take the inverse of the negative. The reason being is we want to find the reference angle. The reference angle will allow us to find the angle in the fourth quadrant very easily. So when we go and take the inverse of this, what we're going to do is we're going to take the inverse of the positive value, or the absolute value of the function value. Okay, so I've got this already open for us, and we're going to put in 0.1611 and hit enter. And we get about 80.85. Okay. So, 80.85, and again, we are dealing in the fourth quadrant, so here's our rule. 360 minus 80.85 is going to give us an angle of 279.15 degrees. Okay, so theta is approximately 279.15. All right, so, pardon me. The next thing we're going to talk about is bearing. This is the second type of bearing that we've spoken about. This one's going to discuss aerial navigation. Directions in aerial navigation are given in degrees clockwise from north. Okay, clockwise, not counterclockwise, but clockwise. So east is 90 degrees. South is 180 degrees, and west is 270 degrees. So I know it's a little tricky to think about, but this is what it winds up actually looking like. Okay, so let's look at a few of them. Okay, so how we're going to set this up is, again, this is my north. This is my 0 degrees. Okay, they're given from clockwise north. Okay, and I know I'm not straight lines here. This is going to be my east. This is my south, and this is my west. And that should make sense because of how we look at a map, right? Except our rotation, where we've gotten used to going counterclockwise, we're going from north clockwise. Okay, so if I wanted to look at a bearing of 50 degrees, that bearing of 50 degrees would look like this. Standard position would now essentially be here, and 50 degrees would look about like this. Okay, a bearing of 50 degrees. So let's look at what 115 might look like. So again, we've got north, east, south, and west. 115, here's 0, here's 90, here's 180. So 115 may be about here. Okay, so the rotation diagrams are shown the same way, but you're remembering that your rotations are going clockwise from the north. All right. So let's look at an example of this. An airplane flies 218 miles from an airport in a direction of 245 degrees. How far south of the airport is the plane then? How far west? All right, so what I'm going to do is I'm going to draw a picture of this. And again, keeping in mind that it's not our norm, okay? Here's our north, which we know to be 0 degrees, and our east, which is 90, our south, which is 180, and our west, which is 270. All right. We know that the plane, let's pick another color here, the plane has gone 218 miles from an airport in a direction of 245 degrees. Okay, so we want to draw in the angle 245 degrees. Remember, we're starting from 0. 245 is probably going to be about here. That's your 245 degrees. Now, it has flown 218 miles from the airport. So let's say this is the airport, right from the origin, okay? 218 miles. So that's the length of this vector here. What we can do is from here, let's say the plane stops here, okay? We can create a right triangle with that x-axis. If this is 245, and we know that this is 270, I can very easily find this angle. And quick and easy here, 240 to 270 is going to be 25 degrees. Okay, so now I have 218, I've got 25 degrees. So what I'm looking for is how far south, so here's my south, and how far west I have gone. So here's my west. Okay, so let's go ahead and find those values. Let's go ahead and find B to start. All right, so I've got my triangle, and if you need to orient it so it's easier to see, you can do that. 25, B, A, 218 is my hypotenuse. So if I'm looking for B, opposite, and I have hypotenuse, I'm going to be using sine. So I can say sine of 25 degrees is equal to my opposite, which is B, which we're looking for, over 218 miles. Okay, cross multiply. And when I put that into my calculator, we get approximately 92 miles. Okay, let's go ahead and find A. So, again, adjacent over hypotenuse, which is going to be cosine for us. So cosine of 25 is A over 218. Cross multiply. And we get A to be approximately 198 miles. So what that tells us, when we go to put that together, just get rid of this real quick. What that tells us is the airplane is about 92 miles south, okay, south, and 198 miles west of the airport. And I want to see these sentences, conclusive sentences at the end, please. Okay, so that is the whole lesson, a whole 9 minutes for you guys tonight. I hope you enjoyed it. Please come prepared with any questions that you have, and we'll go over them tomorrow. All right, I'll see you then, guys. Thank you.